Hello. Hello Devoxx, hello everybody, and welcome to this talk. We are going to spend the next few hours talking about Java 8 and of something quite particular inside Java 8, which is the stream API and the collectors. And we are going to talk mainly about patterns of code. Of course, we're going to see a lot of code in this talk, about performance and about parallelization. Of course, Java 8 is all about Lambda expressions and stuff. You've all heard about Lambda expression as being the new big things of Java 8. But there is also a new API that made it in, called the Stream API. And along with the Stream API, a new kind of objects called the collectors, that are the subject of this talk, and that are going to, that have been introduced in the JDK, mainly to process data as we are going to see it. You might know this book, or if you don't, you might be interested in reading it or getting what's in it exactly. It is called the Gang of Four. It's quite popular, in fact. It is still sold, whereas it has been printed in 1994, that is 20 years ago. And in this book, which is basically a book about patterns, there is one fundamental pattern called the Iterator Pattern, that has been introduced in the JDK in version 2, that is 16 years ago, in 1998. The collection framework has been built on that pattern, and this is precisely this pattern that is not really obsolete, as we could think, but merely old-fashioned by the introduction of the Stream API. My name is José. I'm an assistant professor at the University in Paris, called Paris 13. Okay, it's a very nice name. I come from applied math and computer science. I also work as an open source developer and an independent. I give training, expertise in various fields, especially in the Paris area. I also have a blog called Java le soir, which means Java at night. Okay, it's mainly in French. And you can follow me on my Twitter account, José Paumard. I'm also a member of the Paris Java user group. Now, the Paris Java user group has been reorganized those last in the past month. But I'm still taking care about the organization of the monthly meetings organized by the Paris JUG. And I've been a co-founder and co-organizer of Devoxx France for 3 years. And I'm also a Pluralsight author. You can find my course online on Pluralsight and also on Microsoft Virtual Academy. I just published a course about Asia and how to deploy Java EE7 applications in Asia. And by the way, as a Pluralsight author, I can also give away free passes to the Pluralsight courses. So if you're interested, you can just come and talk to me. I'll give you that. Okay, so this talk is in 2 parts. The first part is about slides. Sorry about that, but slides is a nice way of explaining things, I think. So mostly slides, don't worry, there is a lot of code in the slides. So we are going to see codes in the slides. And the second part is mostly about live coding, about 80% live coding and 20% slide, because live coding is nice, but I prefer people to understand what I code, so a few slides to explain things is better, I think. Okay, let's jump in. If you have any question, I've got my tablet here. So instead of trying to shout in this big room without anyone, especially me, not hearing you, you can use your Twitter account, and I'll try to monitor the question as they flow in using this hashtag. Okay, let us talk about the Stream API. And the first question I would like to answer, and this will be several parts answer, in fact. What is a stream? Basically, a stream is something very easy to understand. It's a typed interface. Okay, this is the declaration of this typed interface. And it is also a new concept brought inside the JDK by the people who did it. And this is what we're going to see now. What can I do with a stream? The answer is quite simple. It has been built to efficiently process data, both high volumes of data, if I've got really millions or billions of elements to process, but also small volumes of data. If I have only collections with a few elements, it might be useful, interesting and performant to use streams. What does efficiently mean? In fact, it means 2 things. This is why I would like to stress that out. First, it means in parallel. I want to leverage the fact that I've got more than one core in my CPU, Everybody knows that. And second, I would like to build pipelines of data to avoid the computation of intermediate data structure. And we're going to see that on examples. The first question I could ask myself is, why can't a collection be a stream? Why all the methods we are going to see have not been implemented or added to the collection interface? Because there are good reasons for that, in fact. There are good arguments for a collection to be a stream. So why this interface has been created separately? First, my data most of the time when I'm doing business applications in Java, my data is in a collection structure, whether it is a collection, a list, a set, maybe a map even. A map is not really a collection, but it's part of the collection framework. And the second reason is that I've been using the collection framework for 16 years now, so I know that framework very well, well, it's a pity to introduce new stuff to learn in the Stream API. In fact, there are two reasons for that. The first reason is we want to be free to create new concepts and to introduce new concepts in the JDK, and we are going to see those concepts. And we don't want to add those concepts inside the collection framework. Why? Because we don't want to have to unlearn what we already know about the collection framework precisely just to bring those new concepts. It's a matter of separation of concerns. We could say it like that to keep saying things simple. Okay, so what is a stream? There are several key concepts to understand, and I would like to list them here. The first thing is an object on which we can define operation. And by operation, we can think of map, filter, reduce, but also other operations. Second, it is an object that does not hold any data. And this is maybe one of the most important key concepts of the stream. There is no data in a stream. There is data in a collection, whatever the implementation. My data is in a collection. It's not the case in a stream. Third, a stream does not modify the data it processes. In fact, a stream is going to be connected to a source of object. Think of a collection or maybe a socket or something like that. And a stream doesn't want to modify the data from that source. Why? Because I want to be able to distribute this data among all the cores of my CPU. And if I do that, I don't want to come across any kind of visibility problem which would incur putting memory barriers in my code, contention point, and bad performances. So this is the reason why I want to do that. Fourth point, this data will be processed in one pass. And this is a key point. A collection does not process its data in one pass. One operation, one pass. Hello? Okay, so this is exactly what I want to do. I want to process my data in one pass. I want to declare operations on my stream, and then to trigger those operations to process this data in one pass. And fifth point, I want to use highly optimized algorithm, and the stream implementation uses those highly optimized algorithm that can work in parallel. Think about the quicksort, for instance. The quicksort is itself an optimized algorithm. There are optimization on the quicksort, because if you want, for instance, to quicksort a list of elements that are already sorted, in fact, you are going to reach, you are in the worst case of the quicksort utilization. So you need some kind of pre-processing for that. And if you want to go parallel, the quicksort is not a parallel algorithm, so you need to do some kind of merge sort at some point to work with that. Okay, so all the algorithms in the stream implementation are supposedly highly optimized. How can I build a stream? In fact, there are many patterns scattered everywhere in the JDK. We're not going to see them all. We're just going to see a few of them. The first one is I just take a collection, call the stream method on it, and I get a stream of those persons, of those instances of person, a stream of those people. Great. Let us see a first operation on that stream. Very easy. A for each method, stream.forEach. I pass an object that is a consumer. This consumer can be implemented with a Lambda expression, okay, like that. And what does this code do? It just prints out every person of that stream. Pretty easy. By the way, I can also write this Lambda expression with a method reference, which is another syntax for writing Lambda expression. It might look a bit weird, but I think we'll get used to it. Okay, so this method reference is just another way of writing a Lambda expression. It's equivalent. So this first operation for each takes a consumer as a parameter. What is a consumer? It's a new interface from the JDK. It is called a functional interface. We are going to define that. And it's in fact part of a toolbox in the Java util function package. There are roughly, I can't remember exactly, I think it's 40 or so interfaces in this package. The consumer is one of them. What is a functional interface? It's an interface with only one abstract method. It means that the methods from the object class don't count. Why? Because most of the time when I define a method from the object class in an interface, it's just to redefine the Javadoc, to make precisions for the documentations of this method. And the default and static methods that I can put now in Java 8 interfaces also do not count. It can be annotated by functional interface. This new annotation from Java 8 is not mandatory. And why isn't it? It is not mandatory? Just for legacy reason. Suppose I've got a Java 8 application with Java 8 code in it, but this application uses libraries, jars compiled in Java 4 or Java 5, maybe. Inside those jars, there are interfaces with only one method in them. Since the definition does not make this annotation mandatory, I will be able, in the Java 8 part of my code, to implement those interfaces, those legacy interfaces, with Lambda expressions, which is great, by the way. If this annotation is there, the compiler will tell me if the interface is indeed functional or not. That is, if it is not, I will have a compile error, which is nice because an interface now, if you check the interfaces from Java util function, the functional interfaces from that package, in fact, there are many interfaces, and there's a lot of code in it because there's only one abstract method, but 400 lines of default methods, static methods, and stuff. So an interface, a functional interface, can be quite a complex object. So having this functionality is very nice, in fact. In fact, a consumer is a bit more complex than just this accept method in it. I also have a default method called and then that takes another consumer. And if I check the code, what does it do? It just consumes the object with the consumer I'm in, and then pass the object to the other consumer, to the after consumer. So it's just a way of chaining a consumer. What is default method? In fact, it's a new concept from Java 8. It has been added to allow one to add methods in existing interfaces without having to modify the current implementations. And this was very important to achieve as a goal. For instance, the stream method on the collection interface is a default method, and we're going to see that because we're going to see that, well, just now, by the way. Okay, this is the code of the stream method. You can see that it's a default interface, and the splitterator method that is called here is also a default interface defined in the collection, a default method defined in the collection interface. Let us go back to this consumer interface. Okay, so this is the code. So I can chain consumer. Suppose I get a first consumer, C1, and another one, C2. I can build a third consumer. By the way, I can write them with method references. Great. Don't worry, we'll get used to it. Okay, so C3 equals C1 and then C2. This is a way of chaining consumer and creating a third consumer by chaining as many consumers as I need. I need to be a bit careful about concurrency because the C1 consumer takes a list that has been defined outside of the Lambda expression. This list will be effectively final since it is referenced from inside a Lambda expression, but the content of the list itself is mutable. And if I want to go parallel here by just calling parallel on that stream, it means that several threads are going to try to add the different elements to that list, and I will probably come into problems with that because, of course, array list is not a thread-safe structure. So don't do that. This is a bad pattern. Okay, it's written here. We have other ways of doing that which are thread-safe. The problem is that the for each method returns void. So I cannot, once I've called for each on a stream, I cannot call anything more. I cannot add other method. So I've got another method for that, a peak method. And that peak method returns a stream, so I can chain my peak method with other methods like filter, for instance, or other pick methods. That pick method returns another stream. That is a new stream object, a new instance of a stream object. We'll come back on that example later. Okay, so far we saw two methods, for each, which takes a consumer, and pick, that also takes a consumer. The first one doesn't return anything, and the second one returns a stream, and so it can be chained with other methods. Let us see a third method, the filter method, that takes a predicate. What does it do? It just filters the stream. Here, I'm only interested in the people older than 20. Okay, so stream filter, and I pass a lambda expression, which is a predicate. This predicate is person, return person, get age greater than 20. What is this interface? Predicate. It's also a functional interface from that toolbox. It has a test method, which is, of course, its only abstract method. And it has also default method to chain predicates. Chaining predicates is about chaining them with a Boolean operation. So I've got an AND and an OR method, and also a negate method that returns a predicate that is just the contrary of it. It's very interesting to check the implementation of those default methods because they are very simple, very easy to understand. So it's just a good source of inspiration to build new APIs. We can see that, in fact, default methods are not just only about allowing one to add new methods on given interfaces without breaking the current implementations and without touching them, of course. It's also about bringing new ways of designing APIs in Java 8. And this is an example of that. In fact, the AND operation is completely abstract. You don't need to know what predicate it is to compute the AND operation between two predicates, so you can write a default method for that. Great. So if I've got three predicates, I can write this kind of thing, P1 and P2, or P3, or P3, or P1 and P2. Now I need to be careful because those are methods call, and there is no way of handle priority in that. It's not equivalent to write that and to write P1 and P2 or P3 because the AND operation has the priority over the OR operation, but when I'm calling just method, the method gets called in the order they are written. Right. I also have a static method, isEqual, inside predicate, which will return me a predicate just comparing the object pass as a parameter. Great. The code is this one. It's pretty easy. In fact, it's a bit more complicated than that because there is a check to see if the object passed as a parameter is null or not. And by the way, I can also write it with method references. A bit hairy, but I guess we'll get used to those syntax. Great. I also have a B predicate functional interface that takes two elements instead of two. By the way, I also have a B consumer that takes two elements instead of two. What happened in this code? So I take a stream on the list of person, great, and then I'll filter that stream with this operation and put the result in a stream named filtered. The stream and the filtered object are different objects. I already said that. Filter method returns a new object. Another question I'm wondering is, what do I have in the filtered object? Well, I guess that the most obvious answer would be the filtered data. What I have it is the people older than 20. Maybe I could think twice about that, because a few minutes ago, I just told you that a stream does not hold any data. So I am not supposed to have any data in the stream. This is a definition. This is the specification of the way streams work. Okay? So if it does not hold any data, it means that the correct answer is nothing. What do I have in my stream? Answer is nothing. Why? Because the stream does not hold any data. That's the spec. We should stick to it. But then the question two is, what does this code do? Because if I have nothing in the filtered object, then what's happening behind the scene? What this code is doing? And in fact, the answer is nothing. This code is not doing anything. Since I have no data in my stream, returning a new stream does not do anything. It does not compute any kind of result. Calling an operation on a stream, calling a method on a stream that returns a stream, is just a declaration of an operation that will eventually be executed later. no data is processed. Another way of saying it is a call to a method that returns a stream is a lazy call. And the stream API and the stream interfaces are basically lazy structures. And this is the reason why it has been separated from collections, because collections are absolutely not lazy. And mixing laziness and non-laziness on the same interface would have led probably to a nightmare to understand the way it would have worked. Okay, so an operation that returns a stream, the definition you can find in the JavaDoc is the following, is an intermediate operation. And you guess that if I have intermediate operation, it probably means that I also have terminal operation, and yes, this is the case. So stating that a stream does not hold any data creates the notion of intermediate operation and create the notion of laziness in this API. This is really a key point. So if I come back to that code that I just showed you with the pick method and the filter method, this is the exact same example I showed you a few slides ago. I told you it was a bad pattern. What does this code do? Well, since the pick method returns a stream and the filter method returns a stream also, it means that those two methods do not do anything. So this code does not do anything. This code is just a declaration of operations on a stream. But since there is no triggering of those operations, of those computations, nothing happens if I write this code and if I execute it. Nothing is displayed, first. Second, the result object is empty. I don't have anything in my list. Okay, so we got three methods for each pick and filter. They all return streams. They all are intermediate operations. And I also have the notion of laziness and intermediate call in my API. Let us see the mapping operation. What does the mapping do? It takes a stream of objects and returns a stream of another type of another object. Here I've got a stream of person, and I return a string of names. Of course, those two objects don't have the same type, so they are different. That's quite obvious. The map method returns a stream, so it is a lazy call, an intermediate operation. It takes a function as a parameter. Here is the function interface. It's also an interface from this toolbox JavaUtil function. I also have two default methods in it, compose and then. Guess what? To compose method and to chain them. Okay, right. I could have a look, just for the fun of it, at the exact signatures of those methods, because I could think that it's just that, the compose method and super v and extend t. So this is the case. When I begin to work with this function, to play with this functional interface, I will come in a generic problem, even generic nightmare, if you see what I mean. And I also have a static method that we're going to see on examples called identity, which takes an object and returns the exact same object. Great. And by the way, I have special types of function. The first one being the unary operator. A unary operator is just a function that takes an object and returns an object of the same type. I also have a B function that takes two objects instead of one. And I also have a binary operator that takes two objects of the same type and return a third object of the same type too. Great, so this map function is pretty simple in fact, and it's a fourth method in my toolbox of the Stream API. Now I've got this Flatmap method. This Flatmap method is somehow something a bit tricky to understand. What does it do? It is basically a mapping that takes a special function, and that function has to return a stream. So it's a function that takes an object with the current object of the stream it will act on, and that returns a stream of other objects. Excuse me. Let's take an example. I've got a list of movies, for instance, and inside those movies, I've got the actors method that will return a set of actors, the actors that play in that movie. I can map that using movie and returning movie.actors. It will return me a stream of set of actors, since this actors method returns a set of actors. So it's a stream of set, not particularly handy. I can call the stream method on this set, so movie.actors.stream returns a stream of actor. So this function, movie returns movie actors stream, is in fact a function that takes a movie as a parameter and returns a stream of actors as an object. So this function can be used as an argument to the Flatmap method. So in fact, I can call Flatmap with that function as a parameter, and what is returned instead of a stream of actor is the stream of actor that has been flattened. So all the actors are being put in the same stream, so a given actor will appear probably more than once if he had played in more than one movie. Okay, so this is the Flatmap method. This is the signature of that method. It takes a function that returns a stream, but it doesn't return a stream of stream. If it was a mapping, it should return that. It returns a stream which has been flattened. And since it returns a stream, it is also a lazy or intermediate call. It does not do any processing. It's merely a declaration. Okay, so I've got three types of method, in fact. Two consumers, one that doesn't return anything and one that returns a stream. A filter that takes a predicate and returns a stream. And two mapping methods, one that takes regular functions and another one that takes special function that will flatten the result. And what about reductions? Let's talk a little about reductions. Reduction is the last step of the map filter reduce stuff. Here is a reduction, stream.reduce, takes a 0 as a parameter. What's that 0? And the lambda expression, age1, age2, returns age1 plus age2. There are two things, in fact, to stress out here. The first thing is, okay, this is not the first thing. The first thing, the zeros thing, is that I can use a method reference as I write this. I think that we'll get used to it in the end. Okay. The first thing is the first 0 that I pass as a parameter. It is, in fact, the default value of the reduction operation. Suppose that my stream is, in fact, an empty stream connected to a source of data that has been, for instance, filtered out, and the filtered out did not return anything. So it is the value that is returned if my stream is empty, basically. But this default value has also to be the identity element of the reduction operation. And this is the tricky thing to understand. We're going to see that an example. If I do not respect that point, then my computation will fail in all the cases. Okay? The 0 is returned in the case I have an empty stream, no value, so I return the default value. But if I have a singleton stream, it will return the reduction of 0, which is this default value, and this element of this only element of my stream. And this reduction of 0 on P will be used if I got a second element of my stream. So if my default value is corrupted, if it's not the identity element of my reduction operation, it will corrupt all my computation, which is not what I want, of course. So what's going to happen if the reduction operation has no identity value? Because I told you that this default value should be the identity value. Now suppose I don't have any identity value for the reduction operation. I might run into trouble. We see examples of that. Of course, we do not use such reductions. Is it really sure? I'm not quite sure of that. We'll see that on example later. And the second thing I wanted to stress out is that the reduction should be associative. You've probably already heard of that. The sum of integers is, of course, associative. If it's not associative, I will have trouble, and especially in parallel, because in parallel I cannot expect how the computation is being made, and this will change the result of the computation. The sum of integers or numbers, generally speaking, is associative. I think so, yes. Everybody agrees? Yeah? Yes, it is. Okay. This one, this was the easy one. What is this one? The max. Is it associative, the max? I guess so. Yes, it is. The product, multiplication. Is it associative? Yeah? Yes? Yes. Yes, it is. Thank God it is. The sum of the square. Is it associative? Not quite sure it is. In fact, it's not. Okay. The average. The average of two numbers. People think it's associative? Huh? You're all asleep. No, it's not. It's not associative. And this funny reduction, yesterday during a talk, someone asked, there's no method to get the last element of a stream. Now, if you reduce a stream with this lambda expression, you'll get the last element of the stream. So I don't know if this person is in the audience, but this is the answer to your question. I found out that yesterday night, quite late. Okay, so is this associative? Yes, it is. So it is associative. So associativity is not necessarily something that is obvious at once. You probably need to think a little if you want to check if your reduction is associative or not. Let us reduce with a max. Okay, so this is the reduction with a max. And by the way, I can write it with a method reference because I've got a new method on integer in Java 8, which is the max method, just there for method references. I think we'll get used to this syntax, don't worry. Okay, so if I do it like that, and if I reduce an empty stream, of course it will return 0 because this is the default value. Now, if I reduce a singleton stream, in this case it will return 2, which is the expected value. But in that case, since it will compute the max of 0 and -1, it will return 0, of course, because this is a result. And this is not the expected value. That's too bad. And if I give a regular stream with -1 and -2, the result should be -1, of course. But since this 0 computed with the -1 will be propagated to the computation with -2, the result will also be 0 if I run that code. So getting to know which is the identity element of the reduction operation I have is really of importance if I want to have the right value for my computation. The reduction with the max has a problem. And why is that? Because the max reduction, does not have an identity element. I told you that we don't use reduction without an identity element. It's not the case. The max and the mean don't have default value, don't have identity element. And the solution to that has been to introduce the notion of optional in the JDK. That is, if I get the max of a stream.max, and I pass a comparator as a parameter, I will be returned with this new kind of object called optional of integer in that case. What is an optional? In fact, it's a wrapping type. Think about an integer, a regular integer. Inside an integer, I always have a value. The difference is that in an optional, I might have no value. An optional might be empty. How can I use optionals? Well, this is the first old-fashioned way. Optional is present, and then get the result. Not very nice. I can merge those two calls into just one, or else, and pass a default value which will be valid in the context of my application. All right? And if I'm not happy with that, I can also decide to throw an exception and to provide a supplier to build that exception with a nice method reference. Have you seen that? That will be lazily called when the exception is needed. But I could also see an optional. Oh, by the way, those are patterns to build optionals. Okay, nice. But I could see an optional as being a stream with 0 or 1 element. I've got an if present method on that optional and can pass a consumer to it that will be executed if there is a value in that optional. I also have a filter method on it, and I also have a map method on this optional. And by the way, I also have a Flatmap method that takes a function that returns an optional. So it's the same kind of thing as the Flatmap method on the Stream API. And this is very nice because I will be able to build new APIs with that tool. This example has been taken from that book, which is, by the way, a very good book, written by K. Holzman. Let's create this new math class that instead of raising exception if I try to divide by 0 and returning errors if I want to compute the square root of a negative number, suppose I don't use complex number, of course, I will wrap the result in an optional. And if the result is not defined, I will return optional.empty. Okay? So all these methods return optionals. And what can I do with that? Well, I can take, for instance, a list of doubles. I've got this new method on the collection interface. By the way, it's on the iterable interface for each. Take a double, compute the inverse of it, it returns an optional, flatmap this optional with the square root, so I take the inverse of the square root of my double, and if present, I add the result to the given list. Now, if I process the first list from this example, I will have the result with only one element, of course, because for -1 and 0, the inverse or the square root is not defined. So this is nice because it's a new way of programming streams of data without having to bother with the fact that I could have exceptions or things like that. And I had a very nice discussion with a friend of colleague yesterday for lunch. And I came to, he gave me an idea, and I came to a new pattern for that, which is the following. I just take this as a function. It's a function that takes a double and returns an optional of double, which is just this. From this flat map, in fact, by the way, I can write it with a method reference. I think we'd get used to it, okay? I can map, since on optional I've got a map method, I can map that and put the result in a stream. So instead of an optional, I will have an optional of stream of double. This optional might be empty, but then I could, since it is an optional, I can call the or else method on it, and if the optional is empty, return an empty stream. So basically what does this function do? It takes a double, thank you Remy, it takes a double, returns a stream of double that might be empty without exposing the notion of optional. The optional is inside the function and it's not exposed. And if I take this function and take double.stream.flatmap, put this function here, then instead of using this bad pattern that is putting this thing on the list from inside the lambda and the list being defined outside the lambda expression, I can collect that using a collector, which is a thread-safe operation which can go parallel very easily. So this is a new way of writing code using optional, but in fact optional are not visible. They are just used inside the API, and this is the stream API that is used to collect the data in the end. Great. Thank you, Remy. Let's go back to the reduce method. Okay, so I've got in fact two versions of the reduce method. The first one takes the default value as the first parameter, but I also have a second one that does not take that default value as a parameter, and that, instead of that, returns an optional instead of returning the value itself. Okay, and by the way, I can also write that with method references. I think you get the idea. I've got several reductions defined on the stream API, max and min, we saw them. I've got a count reduction, but that will return the number of elements in that stream. I also have Boolean reductions, all match, not match, and any match. And I also have find first and find any. Now, those methods are called a shortcut method, in that you don't need to have a look at each element of the stream to compute them. The fact is, if you go parallel, it might not always return the same value, because the find first, you don't know which thread will find the first value of your predicate, and it can be a different value at each run, which could be a problem in some cases, I guess. A reduction never returns a stream, so it is not a lazy step. It is not an intermediate operation. A reduction always triggers the computation on my stream. And of course, they are called terminal operations. Let's see an example of that. I take the mean here, passing the comparator. It will, what did I do? Sorry. Ah, yes, method reference. Okay, I'll get used to that. Of course, this will return an optional of integer. This is the full pattern of map filter reduce. I've got this all match method, which is a terminal operation, which is also a shortcut operation. And you can see, especially in that case, that processing the data in one pass over the data will lead to great optimizations in that precise case. By the way, I can also write it like that. That's funny. Because this all match is a shortcutting method. And if my first name already breaks the predicate I pass as a parameter, then there is no need to map the whole stream to do that. So processing the data in one pass over the data is the first optimization of the way this stream API works. So what is a stream? It is an object on which we can define operations on data. There's no limit on the size of the data, and by the way, the size of the data doesn't have to be known when I begin my computations. That is, I can build a stream, for instance, on a socket. I can't foresee the amount of data this socket will produce, and it will work either. This is a pipeline approach. We define the operation, map, filter, reduce, and when we trigger the computation by calling a terminal operation on the stream. By the way, one can have only one terminal operation per stream. You are not allowed to build a first stream without a terminal operation, then call a first terminal operation on it, get back the object, and call a second terminal operation on it, on the first one. If you do that, you'll get an exception, and you have to build another stream if you do that. But since there is no data in a stream, since all those methods, those intermediate operations are lazy calls, since there is no computation made behind, it is a very lightweight process, in fact. Let us have a look at the default, at the stream method from the collection interface. In fact, it calls the stream support.stream static method, okay? And it also called the splitterator method. Now the splitterator is a, sorry, excuse me. Yes, it's called the splitterator pattern. And if I have a look at that, I can see that the splitterator will be passed as an object to the reference pipeline.head class, which is the implementation of the stream interface that does the work, in fact. All the algorithms are in the reference pipeline class. But this splitterator object is built from a call to a default method defined in the collection interface that is overridden in ArrayList, hashset, all the implementations of collections in the collection framework. And if I have a look at it, I can see that the splitterator is in fact the object that will access the data, that will read the data for me. Let us see what we need to implement. I've got a first method that is try advance. Basically, it consumes the next object if this object is here, is available. I also have, yes, because the stream does not assume that all the elements are available at build time. Think always about the socket example. I also have a try split method that will be used in parallel. The parallel computation of a stream is built on top of the fork join. We'll come back to that later. So this try split method is used for that. And I also have an estimate size, because since the size of a stream might not be known at build time, this is estimate size instead of size. And I also have default method built on those abstract method for each remaining and get exact size is known. And in this method, exact size if known, I've got a call to another method called characteristics. And this characteristics method is very interesting. If I check the implementation in ArrayList, I can see that in fact it is a set of bits. Here I've got 3 bits, ordered, side, and subside. If I check the hash set implementation, I can see that the bits are not the same. I've got basically the distinct bit that is set to 1. And if I check the documentation a bit further, I will discover that I've got quite a lot of, roughly 10 bits that are defined in this characteristics word to describe, in fact, how the stream is made. For instance, the sorted bit will tell me that the stream is already sorted, or the distinct bit will tell me that I don't have any duplication in that stream. And I have a definition to switch those bits, or to set them, or to set them to 0 or to 1. For instance, the map operation will set the distinct bit to 0. Think of a stream of people. If I map them into a stream of age, I might have no duplication among the people, but duplication among the ages. So setting the distinct bit to 0 is, of course, does of course make sense. And how is it used? It's used, in fact, to compute the result. It's used in the computation for optimizations. So string.stream.distinct, since I have a hash set, this distinct call will not trigger any kind of computation when the stream is processed, .sorted.collect. But if I do the exact same code with a tree set that is sorted instead of the hash set, this time the sorted will not trigger any kind of computation when this stream is processed. No, of course, no quicksort will be called, since I know that my stream is already sorted. And we are going to see that when we go in parallel there, we can leverage this characteristic word. Okay, so there are two parts in the implementation. The algorithms in the reference pipeline class, and I certainly do not want to mess up with that class. It's a very complex code. I don't want to override that. And data access in the split iterator interface that is meant to be overridden. So if you want to connect a stream on your own source of data that is not defined in the JDK, you can just implement this split iterator interface to do that. And by the way, it has been done. I know that there's a stream implementation to work with the coherence cache from Oracle, I think. A few words on comparator, because we saw comparators. I use comparators all over the place. And I just would like to show that to you, to show you that this comparator interface is really a great interface just to study, just to have a look at, to get inspiration to build new APIs in the future. So I've got a comparator, natural order, static method from the comparator interface. What does this natural order method do? It's just that. A static method, and it calls comparators natural order comparator dot instance. And if I check this, what is it? It's an enumeration natural order comparator with only one element in it, so only one instance called instance. I guess you've all recognized this pattern, which is of course the singleton pattern. This is the right way of writing singletons since Java 5, 10 years ago. Of course, nobody here would write singleton like that. I'm pretty sure of that. And I've got two methods in it, compare and reversed, to return a comparator, since the objects are supposed to be comparable, and reverse to create a comparator in the reversed order. And I can write comparators like that, comparing. This is a comparator of person, and I pass lambda expressions to extract from the instances of person, the field or the property I want to use to compare those people. And I can chain them. Comparing is a static method, then comparing our default methods. The comparing function here is the code of the comparing function. It's rather complex. I've got to check to see if this stuff is null. And this is not the complete code, by the way. I have more things because the U type has to be comparable, so it should extend comparable. My return comparator should be a comparator of T, so there's the cast here. But there's a further trick, is that the lambda expression should be serializable. So in fact, I've got this also, this multicast comparator of T and serializable to make sure that this object is serializable. And the same goes for the then comparing method. It's a bit more complex than just that. The function has to take super of T and returns extensions of U. Okay. And once again, it has to multicast the comparator into a comparator of T and serializable. New stuff from Java 8. Okay, so what do we have so far? Intermediate operations, terminal operations, and implementation for the Stream API built on two classes. Great. I also have the notion of stateless and stateful operations, which I would like to show you, and which will have an impact on parallel processing. This is a stream, and I want only the 1,000 first people from that list, so I call this limit 1,000. Now the problem is that this operation, limit, needs a counter, and if I want to go parallel, this counter has to be visible from all the threads of my applications. So this counter has to be probably an atomic long. Any kind of technical trick I will use for that, it will lead me to a contention point inside my computation. So obviously, this limit method, which is a stateful operation, in the sense that it needs some kind of outside information to compute, will be something that will lower my performances if I go parallel due to this contention point. By the way, I have other stuff that will do that. Suppose I take an array list of people. Okay, person.map, I take the get last name, and I want to put the result on a list. If I go parallel on this, I need to take into account that the map semantic is very precise. If the order of the names have to be the same as the order of the people if the stream is ordered. See, if the bit, the ordered bit from that characteristic keyword is set to 1. So before going to parallel, of course this point will be a hindrance for parallel processing. So before going parallel on that stuff, which will not work well, I can call the unordered method on the stream that will set that bit to 0, and that will relax this constraint. And of course it will be much more efficient if I go parallel on that. Okay, so little wrap up on the stream. I've got operations on the stream, intermediate and terminal, stateless and stateful, and this matter of stateless and stateful is important if I want to go parallel. It's really a matter of optimization. A stream can be processed in parallel, and it has a state, these characteristics bit fields, and that is used to optimize computations. And as regards performances, I've got 2 elements, lazy processing, one pass over the data. This is the 2 elements for the performance stuff, and of course, parallel processing. And by the way, I also have 3 other streams, streams of number, int, long, and double stream, that will avoid the unnecessary cost of boxing and unboxing constantly the stream of integer, for instance. If I go back to this example, here I build a stream of person, I map that into a stream of integer, and pay the price of the boxing. Further, I will filter that into a stream of integer, which is a new element. I pay the boxing once again. And in fact, I don't have a sum method on that. Why? Because there's no such sum method on stream of integer. There is one on int stream, long stream, and double stream, and not stream on integer. I've got a method, in fact, map to int, that will convert my stream of integer into an int stream. So I should use that, of course, and on int stream I've got this sum method, which is nice. By the way, I can also write it with a method reference. I told you. We'll get used to that. Okay, but if I check my code more carefully than that, I can see that on person.getAge, I already have an integer there. So instead of mapping to int as the last step, I could map to int as the first step of my computation. And this time, I'm only working on int stream, and will get rid of all the boxing and unboxing stuff. And the result is an int, which is nice. If I take the max, the max has no default value. So the result is in fact an optional int, because I also have optional int, optional long, and optional double. And if I get the average, what should be the return of the average? What it should also be optional int, since the average doesn't have a default value nor identity elements. And by the way, I also have a very nice method called summary statistics that will compute in one pass over the data the count, the sum, the mean, the max, and the average. Very efficient, and I can go parallel on that also. This is very cool. And by the way, if you need other statistics on your stream of number, you can go and check the code of this summary statistic method. It's very easy to understand and very easy to extend. How to build a parallel stream? Pretty easy. I've got a parallel stream method. Can't be more simple. And I've got also a parallel method that I can call on a given stream. And this parallel method will also set a bit to 1 and tell the implementation to do the computations in parallel. It's built on top of fork join, which is a good news because I will not have to program the fork join myself anymore. And this is indeed good news. By default, parallel streams use the default so-called fork join command pool, which is defined at JVM level. So all my stream operation, all my stream parallel computations will be computed in the same fork join pool, which is defined at JVM level. It is shared by all the streams, and this is not necessarily what I want to do. Suppose I have a web server. I certainly do not want my user to deploy applications with stream computations in it, and that will go parallel, and that will completely collapse my server, preventing me from serving requests. So there's a trick for that. By default, this fork join command pool will use all the cores, available cores of my CPU. I can prevent that by setting this property. Java util concurrent fork join pool common parallelism to the number, well, to the parallelism stuff I want to set up for that, which is this one. I could set it to 1 on all web server that will be run with Java 8. I think it probably should be a good habit to take. It looks like a hack, but there's another hack even worse, I think, which is I can decide in which fork join pool I want to run my parallel processing. All right. So I just build this fork join pool and will submit my processing as a callable. This stuff is an implementation, of a callable. Callable is a functional interface, so I can implement that with a method with the Lambda expression, and then submit that to that fork join pool, and that computation will be conducted in that fork join pool. So this also looks like a hack. It might change in the future. Let us talk a little more about reduction. A reduction, for now, can be seen as a regular SQL aggregation, the sum, the mean, the max, the average, etc. But it can be seen in a more general sense, with a broader vision. Let's see the sum, for instance. The result is an integer, the initial value being 0, and it's nice because 0 is the identity element of the sum. I can say, okay, I need to add an element to this result, which is the integer, which is just adding. In fact, it's just the addition. And if I go parallel, that means that I've got 2 partial sums computed on 2 different CPUs, 2 different cores of my CPU. I could do that, and combining the 2 partial results once they have been computed. So that is, I've got 2 partial results, and I need to merge them in a certain sense. And this time, it's in the case of computing the sum, it's also an addition. So first, I build a result with the default value. Then I need an operation to add an element of my stream to that result. And then I need another operation, a third operation, to merge 2 partially computed results into one. Think parallel. So I have those 3 operations. The definition of a container, in that example it was just a simple integer, which will hold the result. Adding an element to that container, this is the regular operation. And then merging 2 partially filled containers if I'm computing the stuff in parallel. This is a much more broader vision than just SQL aggregation. Because with that way of seeing things, I can now see that at 3 operations. First, the construction of the result container, which is a supplier, basically. And it can be a string buffer. Then I need to add an element to that string buffer. It's a function. Take a string buffer and an element, and append that element to the string buffer. And a combiner, that is the function that will merge 2 string buffers by appending the content of the second into the first one. And this is another way of seeing the reduction. In that case, it's just the combination of all the elements into a string buffer. By the way, I can also write that using method references. And I can pass those 3 elements to a special reduction method of the Stream API called the collect method. Collect string buffer new, string buffer append. What is that? It is just concatenating all the elements, which are in this case strings of characters, into one big string. So it's just joining all the elements of that string. And this can be seen as a reduction in that context. By the way, I've got a collectors factory class with many methods in it. We're going to see more in a minute. And I've got a method joining that in fact is a wrapper around all those 3 elements, supplier and the two functions. And I can also pass a parameter to this joining collector, which is the delimiter, which will be put between all the elements. And I can also pass a prefix and a postfix to build the full strings of character in just collecting that like that. And of course, all the corner cases are correctly handled by that collector. But I can go further. My supplier could be the construction of an array list, my accumulator adding an element to that list, and my combiner merging those 2 lists into one. And if I do that, I can also write it with method references. Great. And if I do that, I can collect those three, my stream, by passing those three parameters. Array list, new, this would build an array list. Collection add all. Wrap them into an element from my collectors, which is collectors.toList, the element we already saw in the slides, and that's it. And it will collect all the elements in a list of string in that case. I also have, if I change, the supplier to hashset.new, it will put the result in an hash set instead of an array list, two other elements being the same, and it will build me a set. And by the way, if I want to pass a special constructor for a special structure, I can also do it by passing my supplier, in fact, as a parameter to the toCollection method. But I've got 33 static methods in the collectors interface. We are not going to see them all, of course. We're just going to see a few examples, and in the second part of the talk, I'll show you much more examples of those things. Let us see the grouping by, for instance, method. What does the grouping by do? It creates a hash map in which the key, so it's a hash map built on a stream of persons. I pass a special function called a key extractor to this grouping by method. So it will extract the age of those people, create a hash map in which the keys are the age of the people, and the values, by default, all the people regrouped in the list. And if I'm not happy with that age, of course, and if I'm not happy with that list, I can pass a second collector to this grouping by collector as a parameter, which is called the Downstream Collector, and which will be applied to the list of value, well, to the value itself, which is the list of the people here. So instead of having a list of people, I will have the number of those people in a long. And this collector can itself have a second downstream collector. So I can pass collector.mapping that will do a mapping on the elements of those lists. Here, guest last name. So we have the list of the name of the people in my map instead of the people themselves. And if I want to join all those people of those names into one big string of character, I can do it also by passing a second downstream collector, which is a joining with a delimiter, and it will concatenate all the name of the people for me. So this is just a one-liner, and you can see that with the stream and the collectors, we can build quite complex structures very easily, well, with a little habit maybe, but quite easily either. And if I want to sort the names alphabetically, I can pass a tree set instead of a set, and the name will be sorted alphabetically. And if I want to sort that map, build a tree map, so that the keys are sorted in the in the ascending order, I can also pass the tree map colon new, which is a method reference, to build the tree map to put together the result in a custom map. So here, with just one line of code, I have a tree map. I have a map sorted by keys. The keys are the age of the people, and the value, the list of those people, sorted alphabetically in the ascending order. Great. So, stream plus collectors, new tools for data processing, lazy execution, parallelism. I think it's a nice time to have a little break. Did some of you put any question in the Twitter stuff? Let me check that. I hope I've got some connection. Stream framework is obviously a lazy one, but I see the point. Sorry, it's not a question. Best way to handle exception in consumer, insight for each when error should result into separate error stream. I need to think again about that question. All right. Yeah. Okay. Interesting. Huh? I take it the presenter doesn't like the method reference. Care to explain? Oh, no, it's the contrary. I love it. The method reference is really another way of writing a Lambda expression, and for me, it's really a matter of readability. If you think that a method reference gives you more readable code, then go for it. And if you prefer the Lambda expression, the classical way of writing Lambda expression, then stick to the Lambda expression. But I think that there are many examples in which using method reference are more explicit and more readable. Think about the reducer, for instance. Instead of writing A1, A2 returns A1 plus A2, you can just write integer, column, column, max, and this is probably more readable, more striking when you read the code. Okay. After the pause, use cases, live coding. We mostly live coding, hardly any slides. So, well, I think it's a nice time to have a coffee break. And we'll meet again in 20 minutes. Let's say that? Okay, fine. Thank you. I think we are on again. Maybe we could begin by taking a few questions, because I saw several questions flowing on that Twitter timeline. Why has optional and off nullable method? That is, why should I be able to put null in an optional? I do not think it does make a lot of sense to put null values inside an optional. An optional is just there to tell you, do I have a value or do you not have a value? If you wrap a null inside an optional, I have a value, but it's null. Okay. So I don't think you should be doing that. So having an optional off that cannot take a null value will allow you to completely separate the fact that the people that will use bad patterns, like putting nulls in optionals, and the other one that won't do it. My tablet's switched off. All right. Do I have a T method that duplicates a stream in two streams? The fact is I don't have. And I have a clone method in object that is protected, but it is also protected on the stream interface. So I cannot even clone a stream. I really should build another stream with the same set of operations if I need to. And this is, I heard that this is for performance reason, to allow the JIT, the just-in-time compiler, to properly see all the operations of the stream and to properly optimize them. Are collectors fine or lazy, or both, depending on collectors? No. Laziness, when a method returns a stream, it's always lazy. And when it doesn't return a stream, even if it returns void, it means that you are watching, you are trying to observe a result. And a collector is about building a result and observing that result. So it cannot be lazy. So the collect method itself is not lazy. It is a final method that will trigger the computation on the data. How can we collect multiple times on a single stream? You cannot. You cannot. Straight answer. You can't. You can, if you want to collect several types of data, several categories of data, you can build your own collectors, and you are going to see that on live coding session, to gather all this data. This is basically what summary statistics does. It collects the count, the sum, the mean, the max in one pass over the data. So in one pass over the data, you can collect several informations by building your own collector or your own reducer. Okay. I think I've seen them all. Can I refresh that? Yes, but there's nothing more. Okay, so if you have questions, please try to use that, and we'll make a break at the middle of the next. Sorry, let's it like that. Right, and we'll make. I'll try to make another break to get the questions, and if we have time at the end of it of the talk, which I expect, I'll take more questions. So this second part is about live coding. And I've got two use cases that you can find here on my GitHub account. The first being movies and actors. It relies on a data set that I took from this page. This page is a Robert Sedgwick's page. He's a professor in Princeton University in the US, and he has a page with many data sets for us to play with. The movie file has 14,000 movies from 1916 to 2004, with, for each movie, the title of the movie, the release year of that movie, and the list of actors, and on the overall have got 170,000 of actors in that file. And we are going to play with that. The first question I would like to ask is, which year saw the most movies? In fact, solving that problem is pretty straightforward with the collectors. I've got the collectors grouping by, which just does that. We can build a hash map. The keys of that hash map will be the release year, and the value, the number of movies in that year. And in a second step, we'll get the key value pair with the greatest value. So we need to compare all those key value pair with the special comparator we are going to build to do that. So let us see that. Where's my NetBeans? It is here. Is it big enough? Maybe it's not. Yes? Maybe I should. Okay, is it better? Yeah, I think so. Okay, so what do I have here? I took a summary statistics on this file. So I've got, as I said, 170,000 movies, roughly 14,000, actors, 14,000 actors, 76 release years from 1916 to 2004. So the year that saw the greatest number of movies, I'm going to take my set of movies, build a stream on it, and collect the result in a hash map. I want to regroup those movies by release year, so collectors grouping by. This first lambda expression will tell what property of that movie object I should take for the key. So it's movie.release year. It's an int, by the way. And if I just do that, let me just keep it like that. Sorry. Oops. Like that. If I just do that, it's a grouping by, so it builds a map of release year that is integer. And since I have not specified anything to do with the values, it will be the list of the movies released in that year. So this is my map. Okay. Now, this is not exactly what I want. What I would like to have is the number of movies. So I need to specify a second argument to this grouping by method, which is called the Downstream Collector, and which will be applied on the list of movie here. And this Downstream Collector, I need to check the doc, I've got one that is just called counting, that will count the number of movies in a long in each of those lists. And this time it will be a long. Okay, so this is a very quick way to build this hash map. What should I do with this at the second step is to extract from this hash map the key value pair with the greatest value. So to have the key value pair, I need to call entry set. It is a set, so I can build another stream on that. So stream. And then take the max and pass a comparator as a parameter. Comparing. Here I pass a lambda expression to compare what the element of that stream. And the element of that stream are, of course, map.entry of integer and long, since I built my entry set on this map. So I need to compare those entries. Entry dot get value. This max returns what? It returns, of course, an optional. Of course, this optional will not be empty because I don't have any filtering in that stream, so I will have values in it. So I can safely call the get that will return this time this object. It's no longer this map.entry of integer and long, and this is the year I want to find. Okay, this I can do a little better here. This is just movie release year. It's a method reference. I love method reference. Don't be sure of that. And of course, this is entry.getValue, so I should be able to write it like that. Entry get value. Okay, so this is also a method reference. Let us run that. Year plus year. The year is 1997, which saw the release of 678 movies, which is quite a lot, we can see. Okay, I can do a little better with this comparator here. Here, I'm basically building a comparator by using this comparing static method. I told you that I've got many ways to write new APIs, and checking both the predicate, the function, the comparator, etc. Interfaces will probably give me inspiration for that. But I can also have a look at this map entry.interface. And in fact, in this map entry interface, I also have predefined comparators. I've got 4, a comparing by key and comparing by value, and also comparing by key and comparing by value, and I can pass a comparator to them if I'm not happy with the way those keys and those values are compared by default. So here I can just write it like that, and of course get the same result. Right. So we can see that this kind of problem can be very easily solved with the stream and the collectors and the little habit, of course. Let's go a little further. So the solution, here is to use this map-reduce stuff I have with the stream and the collectors. Imagine the amount of code I would have been writing using the iterator pattern, just for this simple example. Second question, the most seen actor. This time I want to check from this file the actor that played in the greatest number of movies. And there are two ways of doing that. One which is wrong, we're going to see this one first, and the other one which is right, of course. We can build a hash map on that. The keys are the actors, the value, the number of movies in which the given actor played, and get the max out of that. I can build a set of actors by taking the stream of movies, flat mapping this movie by checking the actor stream, which is in fact the example I showed you in the first part, collecting that into a set. I will have duplication in this stream, but the set will remove for me those duplications, which is nice. And from that actor, I can build a stream of actor and collect that into a hash map directly with a collectors.toMap. Why? Because I'm not building a map using the key as a property of the actor object. I'm building a map with the actor itself. So it's not a grouping by this time, it's a toMap. So I pass the function .identity because the key is the actor itself. I can write it like that. And I will need to count the number of movies in which this actor plays. And the problem is that I have a movie and a set of actors inside this movie. I don't have the contrary. So I need to go from the movie, build a stream on that movie, and remove from that stream. I need to count the number of movies in that stream, but first remove all the movies that do not contain this actor. That is, only keep the movie with the actor in it. So the predicate will be movie.actors.contains the actor I'm looking at. This way of writing things is correct from a pure functional point of view, and it works. I wouldn't say it works very well because it has a problem. And what is this problem? Is that even if I go parallel, it takes a good 40 seconds to run on a good machine. It's not an old machine, pretty recent machine. And why? Why is that? What am I doing here? I am basically looping over 170,000 of actors, and for each actor, looping over 14,000 movies. So this contains method here will be executed about 2.5 billion times, right? 2.5 billion, which is quite a lot, in fact, which is quite a lot. If it takes 1 second to compute this contains method, it will take 60 years to run this code, more than that even. So more than a lifetime, probably. You better have a set here. If the actors was a list instead of a set, it wouldn't take 40 seconds to run, but hours, maybe days or weeks. I don't know. In fact, I didn't even try. So this is clearly not the good way of doing things. This is the brute force method, the brute, brainless way of computing things. You shouldn't be doing that. In fact, the answer is much easier than that. If I check the code that I wrote to extract all the actors from my movies, I had this flat map stuff, and here in this flat map, I've got a stream of actors, and if a given actor played in 2 different movies, it will appear, he or she will appear twice in that stream. Okay? So instead of collecting that into a set and removing the duplicate, I should keep the duplicate and build my hash map out of that. And this is what I'm going to do. Let us see that. And it will not run in 40 seconds. You can trust me. So stay there. Don't go and grab a coffee. It's not the right time. Okay, I already have my set of actors. Sorry, I need to go from my movie streams. Build a stream from that. Sorry, what was the code again? Yeah. Okay, I need to flat map that. Take a movie. Movie.actors.stream. Here I've got a stream of actors, with duplicates. I'm going to collect that this time in a collectors dot grouping by actor and collecting by counting the number of actors. Okay, this can be written as a function that identity is the same, and this is a map. The keys are the actors, and the value, the number of movies that actor played, which is a long, since the collectors.counting returns a long. It is a map, and this is the result. And if I want to the greatest key value pair, this is the exact same code as the one I typed in just here. So I can just copy paste it. No problem. The get is it's no longer a map, but merely a map entry of actor long. Let's call that actor. And let us display this guy. Let's run that. So you can see it didn't take 40 seconds to run. It was instantaneous, of course. So the most seen actor is, in fact, Frank Welker, that played in 90 movies from that file. Okay, I think we have the Internet Movie Database, so we are going to be able to see this dear sir, Mr. Frank Welker. In fact, it's not really the most seen actor, because Mr. Frank Welker is merely a voice. He plays cartoon characters, so it's merely the most heard actor and the most seen actor. I took this picture from a fan page that gathered all the characters of Frank Welker, animated, in fact, because he's, in fact, giving his voice to all those characters. So thank you, Mr. Welker, for that. Tricky question, the most seen actor in a given year. This is a bit more tricky because this time I need to separate all the movies year by year and in fact to build a hash map of actors and number of movies for each year. So in fact this time to solve this problem, the problem is it's a hash map of hash maps. Okay? The key are the actors, the value are the hash maps. It's not exactly that, in fact. The key will be the release years, and the values maps with the actor and the number of movie they played in during that given year. So if I take my previous code, this one is the code we just wrote. It's barely the one we just wrote. I can, in fact, regroup. I'm sorry, this code is wrong. It's just not correct. So we are going to see. Okay, the flat map should not be there. Excuse me, the flat map line should not be there. So I need to collect my movie stream by release year. Okay, so this is a big hash map. Each key is the release year it will be the release year for all the movies. And inside those, I've got another hash map. The key from that hash map is the actor, the different actor that plays during that release year, and the values, the number of movie in which they played. So this is basically another downstream collector. The problem is that I do not have this downstream collector at hand in my toolbox. So I need to build my own custom downstream collector. And remember from the first part, a downstream, a collector, which whether it is a downstream collector or not is of no importance. A collector can be built with 3 elements. First, a supplier, then an accumulator that will add a given element to this container, mutable container, and then a combiner to combine 2 given elements. And this is what we need to do. We need to build our own custom downstream collector, and this is what we are going to see now. So we need 3 things to build that collector: a constructor to build the resulting container, an accumulator to add an element from our stream to the container, and a combiner that will merge to partially filled container. The approach is always the same. So let us do that. And this time I'm going to check the time it takes to run that code, because it runs quite fast, but not as fast as the previous examples. Okay, so what do I need to build? I want to build a hash map. The keys of this hash map are the integer that is the release years, and the value are other maps with the key, the actors are as keys, and the number of times those actors played in movies. I could write it like that, if it's more easy to understand. Number of movies played. Okay, so the downstream collector will build this structure. I can begin to write the code and see how it works. I will go from my movie stream, okay, and collect, grouping by movie.releaseYear. This is where I need to put this handcrafted downstream collector, and that will be it here. So this downstream collector is defined on a stream of movie. So all my Lambda expressions I'm going to write are going to take movies as parameters. So the first element I need is the supplier. It's a supplier of this map here. Sorry. The supplier of this map here. So this is a map of actor and here I could put a long, but I'm merely use an atomic long, because if I want to go parallel, atomic long will be the right way of dealing with number. So this is my supplier. Supplier is very easy. It doesn't take any parameter. So it's this Lambda expression, and it just builds a new hash map. A supplier is always very easy to write. Might not be the case for the 2 others. So the second element I need to write is in fact a B consumer that will take a map of actor and atomic long, which is my mutable container, and the element I want to add to that B consumer, which is a movie, and this is the accumulator. Okay, so it takes a map and a movie as a parameter, right? Why does it take a movie here? Because I'm dealing here with the streams of movie. So this is why I have a movie here. A movie here, and I need to add all these actors from that movie inside that map. So I need to get the actors from that movie, and for each of those actors, do something like that. Map, I will just write the beginning of the code, put actor, and something is here. I need to increment the atomic long here. Okay, this is not Java code. Java is not smart enough to compile that code yet. Okay, and this is a B consumer, so that's it. All right. What is this code here? Okay, if that actor does not exist as a key in this map, I will need to create a new atomic long. And if that actor does exist, I'll need to get that atomic long and to increment it. Okay? In fact, I have a method for that, exactly, which is called compute if absent. This is a new method from, so it does not compile because there's a name collision here, I think. So the compute if absent is a new method from the map interface that does exactly that. It takes a key. If that key is not here, it will build a new atomic long. Sorry. Yes, but I can't call it actor because I will have a name collision. Atomic long. This is lambda expression that is executed in the case this actor does not exist. For each, sorry, I forgot because this is, I think I need to call it actor 1 once again because I've got a name collision. Okay, so compute if absent, this is an actor, this is the actor of the for each. This is the key. If it's not here, I will execute this lambda expression, that is create a new atomic long with 0 in it. And in all the cases, this compute if absent method will nicely return the current value, which I can increment and get. Like that. I think NetBeans is a bit lost with the auto-completion. So the compute if absent will either create a new atomic long if the key is not present, either do nothing if the key is always there, and in both cases it will return the value whether it has just been created for me, whether it was already there. So I will get either an atomic long with a 0 in it that will increment, that I will increment, and this is exactly what I want to do. And if this atomic long was already here, I will increment it also. So this is my B consumer that will, in fact, add this given movie to my hash map. The third element I need is a B function, no, a binary, yes, big function, but a special B function, which is a binary operator. What do I, operator, here. A binary operator of this map. And what will it do? This is a combiner. What will it do? It will, sorry, I'm missing a cat here. Great. It will take two partially filled hash maps on two that have been computed on two different cores of my CPU and merge them together. So I will take map 1 and map 2. And the semantic is that it should return a map because it is a binary operator, and I will choose to return map 1. And here in that code, I need to add all the key value pairs from map 2 inside map 1. So I will get the entry set of map 2, and for each of those... Sorry? Put all here? Ah, I was about to use merge. You don't like merge? I don't think I can use put all. So this is entry, and since I think I already used entries, I will call it entry 2, just to be sure. In fact, I'm not sure. Okay, so what should I do with this entry 2? I need to merge this entry 2 inside my map. Merge, once again, is a new method from the map interface. It takes a key, an atomic long value, which is the value I want to add to that key if it's not here. And if I already have a value associated with that key, it will take a B function that will take two atomic longs that will merge them. So merge. Sorry. So first it takes a key, which is of course entry2.getKey. If that key is not present in map 1, I will just add the value from entry2. And if that key is already present, then I need to merge those two atomic long into a new one and return a new atomic long of al1.get plus al2.get. And that, I think that's it. Okay. Here I could also take the value from AL2 and add it to the content of AL1 and then return AL1. It would be another way of doing that. Great. Where am I here? I'm here in this for each. So this is done for this for each. Sorry, for some reason I've got an English keyboard now, so I'm in trouble. Oh my God. Come on. Okay. Where can I switch to French keyboard once again? Oh no, please. Yes, but that shift did not work for some reason. I tried that several times. Okay, so this is my combiner. So now I've got my supplier, my accumulator, and my combiner. This code is a bit tricky to write, but once it is written, I can build. Oh no, come on. Oh my God. Ah, I've got it. Collector. So it's not collectors this time. It's the collector interface. On the collector interface, I've got the off method to directly build a collector from that. And I can build collector directly from supplier, accumulator, and combiner. And I can also need to provide this characteristics keyword we saw in the first part, which is in fact available from collector here. I've got several such characteristics predefined for me, and I just need to use this one if I want. So this piece of code, which is basically a one-liner, okay, even if it's a complex line, it's still a one-liner. I'm sorry, this is the case. It is a map of what? Release year, that is integer, and this stuff which builds a map of actor and long. I don't see why. Map 2, and it doesn't compile, which is great. So, sorry? Yes, atomic long, you're right. Thank you. Atomic long. Okay. So now, what do I need to do? I need to extract the max of all this stuff by atomic long. And this is a bit tricky. This is a two-step process, in fact. The first thing I need to do is to transform this map into a map of integer. I'm going to copy-paste this code here. A map of integer and map.entry of actor and atomic long by maxing the atomic long over the years. So this time I will just have a simple map, and in the second step I will get the map entry of that. Okay. So it's once again a collecting process. I need to collect, I need the entry set of that, take the stream of this. So at this point, what I have here is this type map.entry of integer, which is the year, and actor and atomic long, which is the number of moves in that year, and collect that in another collector, to map. This time to map, it's not a grouping by anymore. And I want to get entry. I already had entry, did I? I think so. Yes, entry 2 here. So entry 3. I don't want to have name collision. Entry, and here, so, entry dot get key, because I don't want to change, entry 3 dot get key, because I don't want, okay, NetBeans seems to be a bit lost once again, because I do not want to change the key value pair of that. And for the collectors here, entry 3, then this entry 3 dot get value, it is my map of actors and atomic long, and from that map I want to extract the key value pair with the greatest value, which is the exact same code I already wrote. I know how to do that. It's just a matter of taking the entry set, the stream, and taking the max, supplying the comparator or the map.entry comparing by value. Now my problem is that atomic long is not comparable, so I need to tell him that this, I think that if I just pass atomic long, long, it should work. It doesn't. Why so? Oh yes, it's not map here, it's max. Thank you. And just get the result, because of course the result will not be empty. Comparative by value. Oh yes, so I'm very glad we have this kind of error message, because I'm happy to show one of you. For those one of you with a good sightseeing, you can try to read that and try to understand that. And you need a good pair of glasses and a brain that is not made like mine. Sorry. So I'm going to comment that and to do it the old way, because I sometimes have problem with the compiler. So the comparator, I'll build the comparator in the old way. Comparator, comparing, and what should I compare? This is another entry, so entry 4. So entry 4 is the map entry of that, so I need to take the get value of this. This is the get value of this map entry here, so the get value returns an atomic long, and from that value I need to return the get, which will return a long, which is hopefully comparable, and so now it should be happy. So this is for my map. Okay, great. So maybe we can make a little break here. What do I have here on this map? I've got here this map of exactly what I want here. I will remove this. I do not need it anymore. So this is a map of integer, and this code extracted the map entry of the actor and atomic long with the greatest value of the atomic long. So now I'm nearly done. I just need to extract the map, the max, for instance, from this map, with the value being this stuff, and comparing by the atomic long, which is here. By the way, I'm a bit worried. Why doesn't it compile? J'ai encore une parenthèse dans les choux. Ah, yes, because I need this one. Okay. I can check the type of this, of course. Equals, which does compile, which is great. So it is still a one-liner. Huh? But it's not quite over yet. So, okay, so this is the right type. I will remove this semicolon here. Okay, I'm going to take the entry set once again, take the stream of that. So this is a stream of what? Of basically this type being a map entry instead of a map. Okay, and I want just the max of it. I do not need to map it whatsoever. So it's just a max, and I need to pass the comparator as a parameter, comparing entry 4, I think. Okay, and what do I need to get to compare this? I need to first get the value of this map entry. I'm watching this map entry here, so I need to get the value here, which is this map entry of actor and long. So this is the get value. If I call the get value on this, sorry, get value. Okay, I will have this map entry here. So if I call the get value once again, I will have this atomic long here, and if I want the long inside the atomic long, I still need to call get to have it. Okay, and since this is a max, it will return an optional, so I can call the get method on that optional to have the result. And hopefully this should be this guy, which I need to call here. And this should be the most seen actor in a year. And it still does compile, which is really amazing. And oops, I got a problem here. Yes, because entry 3. Okay, thank you. All right. Now it does compile, and it is still a one-liner. I'm sorry. But it is still a one-liner. Let us remove that. Let us run that code, please. So you see, it's not completely instantaneous. It's still running 100 milliseconds, roughly. And the actor is Phil Horn. In 1999, he played in 24 movies. This code is not that simple to write, probably not that simple to read neither, and that simple to maintain, but can you imagine the amount of code I would have needed to write if I only had the iterator pattern? I'm really worried. And by the way, this dear sir, Phil Horn, thanks to IMDb, we can have his picture. We probably saw him in many movies because he appears in so many movies, but he doesn't have the first role, of course, in all those movies. Right. So this is the first live coding session I wanted to show you. Maybe you have questions? Maybe I could check that here. A nice time to see questions. Yes, why all the diff entries? Because I've got name collisions. If you call all the, it can really become a nightmare if you don't, if you name your variable with the same name. Of course, you have rules; they are scoped and things like that. But if you take that, you'll have compiled errors that are really not explicit, and it will make your life much more harder. Vas-y, dis-le, je le répéterai. What Remy is saying is that it was a discussion among the experts group to have those name collisions or not. If you're not happy with that, just say it, post on the mailing list of the OpenJDK, and maybe things can change in Java 9, right? Okay. Okay. The second use case, I wouldn't say it's simpler or not. It's roughly the same kind of stuff, but different. It's called the Shakespeare plays Scrabble. Of course, Shakespeare never plays Scrabble because there are a few centuries between Shakespeare and the Scrabble game, as you all know. And it's an example I built on two files from this page from Robert Sedgwick. The first file is the OSPD, which is the Official Personal Scrabble Dictionary. And the other file is all the words used by Shakespeare in his literature. And I say, oh, that's nice. If you go and check Wikipedia, you can find, because I'm French, so I've got a French Scrabble, but Shakespeare didn't write many things in French. It's mostly in English, of course. So I was needed the score of each given letter from the Scrabble game from Wikipedia. So this is the case. It's in Wikipedia. The first question I'd like to ask is how to compute a given score, the score of a word in Scrabble. Well, it's pretty straightforward. You take the word, you take the scores of each individual letter, you sum them all, and here, for this case, the result is 8. So basically, what does it do? This is a stream of the letters of the hello word. You can map that stream to a stream of integer, merely to an int stream with the score of a letter, and sum it all, and it will give you the result. So it's basically a map-reduce problem. So let us do that. It's pretty simple. It's called the Scrabble example. What do I have here? I've got 25,000 words in the Shakespeare dictionary and roughly 80,000 words in the Scrabble dictionary. So the first function I'm going to write is a function that takes a word, so a string of character, and that returns the score of that word, integer. I'm going to call that function score. Takes a word. I've got a nice method on a string class, this good old string class, which is a car method that returns an int stream, not a stream of integer, but an int stream with the letters in it. I can map that stream, and changing that letter to this array I have here, which is the Scrabble and score integer array of integer, and use this old trick from C code to read the right cell of that array corresponding to the letter, and just sum the result to get the score of a given word. Now this time it's a real one-liner. Okay, so this is the score of a word, pretty simple. Now, how to compute the score of a word? It's a MapReduce problem. How can I compute the score of the best word of Shakespeare? This is once again a matter of building an histogram with the key being the score of the words and the value being the list of the words, max by the key value. We already done that, so it's pretty straightforward. The first one is a hash map built with the collectors grouping by, and it shouldn't be too hard to max by the key value pairs. We've already done that. Let us do that. Okay, so I take the words from Shakespeare, stream, collect in a collector grouping by, get the score. And for now, I'm not going to watch all the words themselves. I'm going merely to build the real histogram with the number of the words. So this is a map. The keys are the score, so the score are integer here, so integer. And the collectors that counting puts a long in that map. So this is my map, and I can print it. Okay, so it tells me, I don't know if it's readable, maybe I can zoom this a little. It tells me that I have 2,300 words worth 10 points, and I have 2 words for 40 points. Now, it's not very nice to have it like that, because I would like to have this 40 here, the max at the beginning of it, so I can pass a further parameter here, a tree map new, that will build a tree map instead of a regular map. But this tree map, in this tree map, the keys are in the ascending order. So if I want to have the keys in the descending order instead of the ascending order, I need to pass this time. I cannot use the method reference this time, but this time the comparator dot natural order dot reversed, and it will do the trick. Okay, so I've got 2 words for 40 points. Let us filter that stream. Filter, word score apply word greater than 40. Okay, so I just selected those 2 words, and now instead of counting them, I'm going to collect them in a list, thus changing the type of the map here, map, integer, and list of string. Okay, let us run that. So the 2 best words of Shakespeare are this one, honorific abilit unitatis. Aha! Now you do it. And Nebuchadnezzar. I'm not sure what it is, but I discovered a few days ago by watching these old movies, well, old for you, not for me, Matrix, that it is the name of Neo's spaceship. Don't know why. Okay, so obviously this word is a bit. I don't think it will fit on the Scrabble board. You know, it's a bit too long. So what I can do here is, in fact, add a filtering step and check if this word is contained in a Scrabble dictionary. And by the way, guess what? Contains. This is a method reference. Okay, so I will remove this filtering and check the histogram once again. I've got one word worth 33 points. Maybe I could have a look at it. 33. Okay. And this word is whizzing. Great. Let's back to the slide. So to filter out the wrong words because the word was too long, it's just adding a filtering step that I just showed you. It's the solution is once again a map filter reduce solution. Now the question is, can one really write this word in the English Scrabble? In the French Scrabble it's not possible because I only have one Z in the French Scrabble. But I was not sure for the English Scrabble, so I came back to my friend Wikipedia to find that, yes, indeed, there's only one Z in the English Scrabble. So in fact, this word cannot be written as is. I need to add another filtering step to check if I have all the available letters in my game to do that. The letters I need one W, etc., two Zs, two I, two Zs. The available letters are only one Z. So I need to compare all those two lines of numbers, and this is basically an all-match method, pretty easy to reduce, and to build a new filtering step with this one. Let us do that. Let us add a predicate of string, because it will take a word as a parameter. Let us call it can write, for instance. It takes a word. I'm going to build yes, before doing that, I need to do something else. The first step is building in fact, is counting the number of letters I need to use for writing the given word. So it's building an histogram of those words. So the first step I need to do is to build a function that takes a string and that will return the histogram of the letters for that word. An histogram is a map. The keys of this histogram are the letters themselves, so integers, and the value of that histogram, the number of letters used to write this word, so they are longs. And I'll call this function histo. Take a word, build the stream of letters on that word. Now I'm going to build a hash map on it and to use the collectors grouping by, as I did. It is not defined on the int stream, so I need to box that stream into a stream of integer. So map to obj, integer, column, I think I've got a value of something. Yes, great. I will leverage the fact that I've got a cache in the integer class, not to create new objects for that. And now I can collect, this stream, collectors, grouping by. I regroup that by letter, and I already have a stream of letter. And I need to count the letter, so it's just a collector that counting. And that's it. This letter, not very nice, I can use the function .identity for that. You see that here I'm using a method reference. Is it more readable to write it like that than to write letter, new integer of letter? It's really up to you to decide that. Okay, so this is my histo function. So here I will build my histogram on my word, histo, apply word. So this is my hash map of letter and number of letter. I need to take the entry set on that hash map. And a stream on that. So this is a stream of what? Of map.entry of letters that is integer and number of letter that is longs. So on that, I can apply my all match predicate. And this all match takes an entry as a parameter. Okay. And what do I need to compare? I need to compare the entry, the entry.getValue. Entry.getValue is the number of letters needed to write that word, and it should be lesser or equal than the available letters in a Scrabble game. So this is, I need to read that array to do that, and to read it for that given letter, which is entry.getKey minus A. So this is my predicate can write, and I can add now this filter here. Filter, just can write. Since can write is a predicate, I just have to write can write in my code. Okay, I'm going to comment that out to check the histogram once again. Run that. Now the best score is only 26. Of course, it's lesser than the previous one. So let us have a look at the 25 too, maybe, instead of counting, getting the list. Let us run that. So the words are squeezes with an S, Jezebel, and quickly for the Shakespeare dictionary. Not bad, 26, that's nice. Okay, so the solution is once again a map filter reduce step, and it can be, I won't say easily, but it can be programmed, coded with this stream API. But the problem is not quite over, is it? Because I've got blank letters in a Scrabble game. I've got 2 of them, right? So if I can't write the whizzing word like that, because I've got 2 Z's, I could write the whizzing word like that, with 1 Z and with a blank. Another question is, what is the impact of trying to take into account the blank? In fact, it has 2 impacts. First, it modified the way I filter the words, because this time it's not about just comparing the available letters, but it's in fact counting the number of blanks I need to write that word and checking if it's lesser or equal than 2. And it has also an impact on the computation of the score. Why? Because the second, the blank scores 0, so the second Z should score 0. Okay. How can I compute the score? The first way I had to compute the score is wrong now. I cannot use it anymore. In fact, I can go from my histogram of letters here, just multiply the number of letters by the score. Compared to the number of available letters, and here I only have 1 Z, and then multiply the result, and this result is a mean between the number of letters I need and the number of available letters, and multiply that result by each individual score and do the sum. And it will do something like that. Okay, so let us do that. This is the third way of, this is the second way of computing the score. It's a function that takes a string, which is a word, return the integer that is the score of this given word. Take the word, compute the histogram. I'm going to copy paste this code because it is exactly the same. And from that, so this is my stream, I need to map to int something, and to, at the end of the word, sum my stuff. So this is, I take my entry, which is a key value pair from here. I need to take the score of that given letter. The score is read from the Scrabble and score for this letter and this letter. This is entry.getKey minus A. And I need to multiply that by the number of letters usable for that word, that is the mean between the needed letters and the available letter. So since it is an integer, I'm going to take min integer, integer.min, sorry, between entry.getValue, which is the number of letters needed to write that word, and this thing, copy paste that, which is the number of available letter for that letter. It does not compile because this is a long, so it's not happy with me trying to convert a long into an int, and this is the same here. So I need to convert that to an int. And this is the second way of computing the score for Shakespeare. It is not quite over because I also need a method to compute. So the solution is once again a map filter reduce solution. And I also need a method to compute the number of needed blanks for that word. I need two z's, but in fact I've got only one available. Now if I subtract those two lines, I will have, of course, negative numbers, because, okay, it's like that. But I will have also positive numbers. And the positive numbers are the number of blanks I need to write that word. So in fact, what I need to do is to take the max between 0 and the subtraction of the available letters minus the needed letters, and make the sum of it. And this is the number of blanks I need to write the whizzing word in that case. So let us do that. It's once again a function, and I'm going to copy-paste that directly. It takes a string, which is a word, returns a long, which is the number of blanks I need to write that word. I'm not going to call it a score2, but n blanks. Okay. Take a word, apply the histogram, take the entry sec, take the stream, and then, since I want to return a long, I'm going to map to long instead of mapping to int, and sum the result. I've got my entry here, and the result is a long, and this time it's not a min, it's a max, between entry.getValue, which is the number of needed letter, and the available letters, this one, and I need to subtract the result. It doesn't compile because I don't know why. Long. Yes, because I need to compare this with 0, of course. Okay. Thus, if I've got negative number, those negative number will count for 0. And this is the number of blanks I have that. How can I use these new ways of computing the score, a new way of using the blanks? In fact, the second filtering is just, I need to tell the system that I will accept n blanks apply word with only 2 blanks. I will comment that. And here, take the second scoring function instead of the first scoring function. Let us have a look at the histogram. Okay. There's something wrong in the result, sorry. It's this one. Is it this? I'm not sure. Yes. Yes, it's this one. Okay, so I still have a word with a 26 and 2 words with 25. Let us have a look at them. It still squeezes Jezebel and quickly. In fact, I can write this word with blanks and with this new scoring function. And what's nice on this tree is I also have the words, a file with the words of Dickens. So we can have a little Scrabble match between Dickens and Shakespeare. And check that, in fact, Dickens used the squeezed with a D, was 2 points, instead of the squeezes of Shakespeare. So Dickens would have beaten Shakespeare by one point at Scrabble, 27 to 26. I'm glad we could answer this fundamental question of computer science together nowadays. Okay, you might think this is over, but it's not quite over. So how many blanks do we need? The solution is against MapReduce. But the Scrabble is not just about making words and computing scores. It's also about putting those words onto a Scrabble board. And if I have a closer look at this Scrabble board, I've got two double-letter squares, not very far from the central square of the board, on which I have to put the first word. And so the last question is, what about this double-letter score? How can I compute the score, the final score of this squeezes word, and the best score, in fact, by taking into account that I will have a letter that will be counted twice instead of once here. Because the squeeze word really fits very well on this board, I can put the Z directly on the double-letter score. Amazing. In fact, I've got six solutions to put that word on the board. I can put either a word that the Scrabble game can only have 7 letters. So the 3 last letters can fit on the right double-letter square on the right side of the board, and the first 3 letters can fit on the left square. If the word is long enough, of course, because if the word is lesser than 7 letters, then it won't be 3 letters, but 2 or even 0. How can I do that? In fact, I can consider the 2 streams of either the 3 last letters of the word or the 3 first letters of the word. Those are 2 streams. Those streams can be empty, but never mind. Let us create a solution with that. I can concatenate those streams into a single stream, which is not very nice because the concat method from the stream interface does not parallel very well. It has a very specific semantic. I will have the the elements of the first stream and then the elements of the second stream. So it's not probably a good idea to use this one. I've got another way of doing that is the stream off method. The off method is a static method from the stream interface. And I can put those 2 streams here. What do I have here? It's a stream composed of 2 streams. The first one with the 3 last letters of my word, and the second one with the 3 first letters of that word. So it's a stream of stream. And this stream of stream, I can flat map it with the identity function. Since this is a stream of int stream, I need to flat map to int just for compatibility, type compatibility reason. Then map to the score, then max it. If my word is only 2 letters long, this stream will be empty, so the flat map will be empty. The mapping will be empty, so the max will return an optional, which is empty also. So in this case, my optional can be empty. But never mind, since I need a max, I can also call this or else method and pass 0 as a parameter. It means that this word will not leverage the fact that I've got a double letter score on my board. This word cannot use that letter score and will get a 0-point bonus. And let's do that. Great. So this is a third way of computing the score. So I'm going to check that function. String integer. Sorry. Let us call it score3. So it takes a word. Stream of. So the first stream is just word.chars. And I'm going to skip the first 4 letters, thus taking only the 3 last letters. Once again, there might be no 3 last letters, because if my word is only 2 letters long, this stream will be empty, but never mind. And the second one will take the 3 first letters. What I would like to do is to limit this by word.length -4, but the limit method will throw an exception if I pass a negative number to it. So just to be protected against that, I can use the integer.max 0. and word length, and that's it. Now I will flat map to int an identity function just to get a stream of letter. Map that, so this is a regular stream of letter. Map that to get the score of that letter, minus A. Take the max. And if my stream is empty, just return 0. Else 0. And it does not compile. Qu'est-ce que j'ai fait? Ah, thank you. Okay, so this is the third way of computing the score. And in fact, I could also add score to apply to the word, to that. So this is a complete score. Since this is the first move of the game, I've got the multiply by 2 bonus. And I've got another bonus. If my word is 7 characters long, I've got this 50-point bonus. So I can introduce that in my score 3 method. Okay. Now, what does it change here? Just change that. Just a matter of changing the score I'm using here. I don't want to change that. So what is the best score? It's 120. Ah, nice. So let us see that. 192. So the best word is still Jezebel, quickly, and I also have the Zephyrs for 118 points that Shakespeare could have put on a Scrabble board at the first move of the game, which is great. So this was, once again, a map-reduce stuff that we can solve with a different way of thinking our application. All the code you see is available, roughly available on my GitHub account, so you can go and grab it and check it and comment it if you like. As we saw, I'm reaching the end of this talk. As we saw, the stream and the collector API is really a new way of thinking our application, of thinking how we want to solve the problem in the application we have. We do not need to use the iterator pattern anymore. Can you imagine the complexity of solving with the iterator pattern the movie examples or the Scrabble example? It would have been much more complex than the code I wrote, which was already complex, of course. I do not really need this iterator pattern anymore, which is really a new way of changing our habits in conceiving our Java application. Combined with the Lambda expression, this is really a new way of writing processings and applications in Java. But it's not only that, it's also about writing code itself, of course, writing architecture, and also writing APIs. Now, this introduction of those new concepts in the JDK is really a revolution in itself. It is the first time in 16 years, we've been playing with this iterator pattern for 16 years now, and it is the first time in 16 years that we have such a change of patterns inside the Java platform. In fact, when you think about it, the introduction of the generics in Java 5 did not change the iterator pattern. But the stream API does change that. And I can tell you that the students who are arriving on the market just now have been well trained with these new techniques. So in 3 years from now, if the current Java developers have not trained themselves at the same level, they will run into big problems, I think. I'm quite side of it, but I'm pretty sure of it too. I think that's it. Since I work at the university, I like to advise people to read books. So go and grab them, read them. Most of the authors of those books are here in Devoxx, so you can also try to get to talk to them and ask them questions and stuff. I think that's all for this presentation. Thank you for your attention. And we have time for questions. I'll get my tablet and see if some of you have brought questions on the stuff. With this all one-liner, could you please show an example of debugging code between the docs in the one-liner? Well, the question, the answer is quite straightforward. Do not write bugs. I don't see what the problem is, really. I think that if you want, this question is a same kind of question as how to write unit tests on this API. In fact, of course, you should not be unit testing the API itself. You should not be testing the way the collectors or the way the stream API work. What you should be testing is your function, your predicate, your all match stuff, your histogram stuff. Unit test that. It's very easy because it's just basic Java code. And once your function and stuff are unit tested, just check that the way you have organized your operations really does what you want to do. And you can also unit test that, and that's it. Now, if you want to debug your code, you can still you can add, of course, carried returns in your code, even if it's a one-liner, and you can put breakpoints in your Lambda expression to see and to inspect the code. This is still Java code, and you can definitely do that. So, of course, it's a new way of writing code. It's also a new way of testing. It will be a new way of testing the code and debugging it. But it's perfectly doable with all the tools we have, whether it is Eclipse, NetBeans, or IntelliJ. In fact, I prefer when predicates and filters are written before. Yes, I think that this is really a matter of readability. I agree with you. There's no rules to that. You can do both. But if you want to have a more readable code, first write your function predicates and stuff like that, and then write the stream ... that will use those function and predicates. I agree on that. But once again, it's more a matter of styling. How should I write a readable code? Why is whizzing not coming out in a solution with the blanks? Because the second Z does count for only 0 points, and it goes after the squeezes stuff. In fact, it is still here, but it's after it. It is still a one-liner. Yes, writing. Okay, it's still a one-liner. Yes, that's true, but that's not a question. Sorry. Is it more important to refactor to reusable part than write one-liner with comments? Tricky questions. I think that you definitely should put comments inside your one-liner when you can, just because if you are interrupted in what you're writing, while you're writing your code, sometimes you need really to have landmarks and say, okay, this is what I have, this is what I have, and ask the compiler if this is really what you have as a type. And if it's not the case, then you can check and fix your code before ending it. And plus, if you write your code like that, you can still hope that the IDE will help you with the auto-completion, which might not be the case, because the IDE sometimes have troubles figuring out what you're doing. I hope you keep also code maintainability in mind when teaching such long one-liner to your students. No, I don't, really. Of course I do. I mean, reading code, we all know that we spend 10 more times reading code than writing code. So indeed, you need to write readable code. Writing readable code with such patterns is not absolutely trivial. It's a matter of organizing your code, indenting your code correctly, I think, and also probably putting comments in it. You know the story. This was a joke on Twitter, by the way, a few years ago. When you write code, you should think that Hannibal Lecter is going to read it and to fix it, and that he got your address. so be careful. He was playing. What's the name of the movie again? Silence of the Lambdas, was it? Looks complicated. No, it's not complicated, in fact. Most seen actor given in a year. Isn't it simpler in traditional way? Try it, really, try it. It's not simple. I don't know, maybe it's simpler, but it's not simple. It's not a simple problem, really. It's not a simple problem. Maybe with more maps. I thought it was complicated enough with 2 maps, but if you want a third one, well, maybe. Okay. No Java anymore in J8 stream. Okay, custom collector with supplier. Okay. Yes, it looks like Voodoo. It looks like Voodoo code. I'm not Voodoo specialist, so I can't really tell you if it's Voodoo or not. I think the fact is, it is still Java, but it doesn't. It's true. I mean, it doesn't really look like Java anymore. When you look at that, when you are really leveraging all those new stuff, the stream, the collectors, with Lambda expression and stuff, you don't really have the code you wrote. I wrote in front of you has barely anything in common with the code we were writing with Iterator, with while and loops and stuff like that. But it's also much more efficient from a pure performance point of view. When you are dealing with a big amount of data, you can go parallel with it, and it will be much more fast to run than in the iterator pattern. In the iterator pattern, everything takes place in one thread, and if you want to parallelize that yourself, you still need to write your fork join stuff yourself. And it's very hard to tune and very hard to gain performance if you do that. So I think that, okay, it might be a bit complicated, especially for us, regular Java developers, I would say, used with to use the iterator pattern and the collection and the loops and the while and the for each and stuff like that. But once again, for the students who are going to arrive on the market in the next few months or in the next few years, it will be very easy for them to use. It won't be any more complicated to use for them than to use the iterator pattern. This is what we should think about. And so the real parameter for that, to decide whether we should go for that or not, is readability, of course, and performance. Is the code faster with those patterns than with the iterator pattern? And the answer is yes. The answer is yes. It is more performant. What about the projection mode? What do you mean? Sorry? You mean Java 8? Oh yes, it's completely stable, yes. Yes. You can definitely go in production. There are projects in production already with that. There were very interesting talks recently in JavaOne by Goldman Sachs, who are already using these kind of APIs and other APIs they developed, by the way, called the JS collection, like Goldman Sachs collection, in production in the trading applications. So yes, you can definitely use that in your applications. Yes, it's not a matter of stability. I can see from my point of view, I can see many people adopting Java 8, and the Java 8 adoption is much faster than the Java 7 adoption was several years ago, or the Java 6 adoption was several years ago. People are really running for it, and sometimes going directly from Java 6 to Java 8 very quickly. Yeah. Are there any more questions in Twitter? Okay, I think that's it. Any more questions in the room, maybe? For those of you who don't have a smartphone or a tablet? No? No more question? Okay, thank you then for your attention once again.